So engineering AI systems is at the heart of making AI real. No, we are turning ideas and models into products that can work reliably in the real world. What are these roles doing? They're blending deep technical expertise with practical problem solving, and they're essential for every organization. Every organization that is which is looking to leverage AI at scale. Okay, what are these roles? AI ML engineer, first thing. They are the builders. They design, develop, and deploy machine learning systems. And I know these systems power real products. What do they work in? Their work is combining data science. Now, what is data science? Like model selection and training with software engineering, right? So once they do that, they ensure that the AI solutions are robust, scalable, and maintainable. Next, we have the data engineers or the big data engineers. See, as you can understand, data is a fuel for AI. Data engineers create the pipelines and storage systems which deliver the high quality, timely data for both AI and analytics. Right? They can ensure that data flows smoothly from source to model, source of the data to the model. Basically, the data is ingested properly, transformed, and stored. So that is the data engineer. Right? Now you have the AI research scientist. Uh, so what do they do, research scientists? For example, in my lab here, uh, I'm also a research scientist at IIT Bombay. So what we are doing is we are building computer vision models. And what we're doing is basically doing research, core research on how the models are working. So we are exploring new models, algorithms, and pushing them into out of a research back lab, sometimes into the real world. Right. So basically, research work will develop the new algorithms, architectures, and work with the product teams around that. So this innovation becomes the building block for new AI products and features. Right. So that's a research scientist. Every company has a research scientist. Google has research scientists and so forth. And research scientists are also there in academic institutions. Now, what is NLP, computer vision, or robotics? They are specialists, right? Some engineers will focus on specific things like natural language processing, computer vision, like I mentioned earlier, or robotics. So the domains are completely different, but the foundations of maths, statistics, and probability, they are the very same. So what are the core skills required here? You programming languages like Python, machine learning with machine learning library like scikit-learn and TensorFlow, PyTorch, data processing tools, all these things. The cloud platforms are also very important. Cloud platforms like Google, Azure, or Amazon. We need to manage AI systems in production. Uh, now we have DevOps. Now there are some DevOps engineers here, right? In the chat we learned. But when you are doing translation to ML, machine learning, you have to learn even as a DevOps engineer, you have to learn MLOps practice. Any model is continuously integrated, automatically tested, and deployed and monitored. So these are MLOps techniques. Like it's like DevOps, but it's for machine learning. And the life cycle is a little different. For code, you have to just compile, test, and deploy. So that is, but ML is different because you have to. The testing cycle is different, right? You have to develop, understand whether the model changed, whether what the accuracy is, and you can have different versions of the same model as well, and different clients may be on different models at the same time. So all these things has to be understood, uh, so that you have to adopt your DevOps practice to MLOps. Okay, so now you understand where you are from. You have to ponder yourself. Are you getting more drawn to building models, designing data infrastructure, or exploring new frontiers in AI research? Like there are some undergrad students here. Uh, so you can understand uh, from this. So try to ponder about it, right?